solubility as the amount of solute in grams required to saturate 100 grams of solvent at a particular temperature. Saturated solution, many of you were just forging life there, but you don't know the answer. I told you when I'm teaching, you should be having a pen and noting some important things. A saturated solution is a solution which cannot dissolve any more solute. A saturated solution is a solution which cannot dissolve any more solute in presence A saturated solution is a solution which cannot dissolve any more solute in presence of undissolved solute. In presence of undissolved solute at a particular temperature. A saturated solution is a solution which cannot dissolve any more solute in presence of a saturated solution. No, a saturated solution is a solution which cannot dissolve any more solute in presence of undissolved solute at a particular temperature. A saturated solution is a solution which cannot dissolve any more solute in presence of undissolved solute at a particular temperature. So let us go to this question of the graph. This is where I think some of you became lazy and they did not plot the graph. The table below shows solubility of solute P. This is the graph that we plotted the other time, but I gave you a question where you are supposed to plot a graph and some of you did not. So I said I'm repeating this such that it can help you to go back and plot the graph and answer the questions. Plot a graph. My graph is here, as we had it last time. When the question says plot a graph of solubility of P against temperature, it means solubility of P is on the vertical axis or the y-axis. Then temperature is on the horizontal axis. Solubility of P is on the vertical axis, then temperature is on the horizontal axis. Against solubility of P against temperature. So what comes first is the one on the y-axis. Solubility is on the y-axis or the vertical axis, then temperature is on the x-axis or the horizontal axis. So temperature is on the horizontal axis, and on the vertical axis we have solubility. Now, that is the title. I told you for me to give you the marks for the scale, I mean for the axis, then you write solubility of P and you give its units. Some of you were lousy enough to write just solubility of P and you walk away. In that case, I also give you nothing and walk away. Write things the way they are supposed to be. This is solubility of P in grams per 100 grams of water. So write the units. And the temperature is in degrees centigrade, as you can see. Now, plotting, most of you showed some skill. You are good at plotting. 1018, we agreed 1018 that we start with the x-axis. So on temperature it is 10 and the solubility is 18. When you use a scale, if you want to be successful here, first find out how many units each small square is representing. You know, when you get your graph paper, you will see this small square, I mean from here up to here. That is the small square. If you are using, many of you use the 10 here. If you have put 0 and you have put 10 here, that means you get 10 and you divide by the number of small squares. And the number of small squares here, they are 10. The number of small squares in 2 centimeters, they are 10. So if you have put 10 here and you have put 0 here, you get 10 and divide by the number of small squares, and you'll get 1, meaning each small square there will be 1. But for me, I've used 5. So in 2 centimeters, there are 10 small squares. So to get what each small square represents, I'll get 5, which is from here up to here, and I divide by the number of small squares, which are 10. So 5 divided by 10, the answer is 0.5, meaning each small square there is 0.5. So if I want 18, and this is 15, the next one becomes 15.5, 16, 16.5, 17, 17.5, and I get my 18 there. But I'm happy most of you tried plotting properly. You plotted very well. Then joining, there was a problem. Some of you, I told you to avoid joining scales, I mean graphs with stomach. Someone, you first draw a stomach here like this, then when you reach here again, another one like that. What are you joining? Be steady. I think at your age, you don't even know how alcohol smells. So I don't know why you are shaking when you are joining. Just get a pencil and target all the points and join at once. This business of joining from here up to here, you first go for short call. You come back, you join from here up to here. Then you go to the kitchen. Then you join from here up to here. You go to the toilet. You come back and join from here. No, 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 no. Join at once the whole graph from here and bring up to there. All the points. That's when you'll be able to get a smooth curve like that one of mine. Aren't you admiring my curve? I know deep inside you are admiring. As usual, you always admire my graphs. Yes, but drawing smooth graphs for me, it is part of me. It is in my blood. So I'm not going to go into details of plotting these points. You can all do that as long as you have chosen a very good scale. And remember, your scale should cover 3/4 of the graph paper. After plotting your graph now, can you be able to answer the questions? Use your graph to determine the solubility of P at 25 and 45. I'm using this as my graph. For you are going to draw yours and use it. Solubility of P at 25 degrees centigrade. I was very clear. I told you, come to your graph, look on the axis of temperature and look for 25. My 25 is here. Then I draw a dotted line very straight with a ruler. Dotted line, I can even follow that line because that's the reason of using a graph paper until I meet the graph. Then when I meet the graph, I will go to the solubility side now. From the graph, I go to the solubility side, as you can see, and I'm there. I will read that answer from the graph, and that will be the solubility of salt P at 25 degrees centigrade. That will be the solubility at 25 degrees centigrade. There. Everyone can do that. Anyone can do that. Then solubility, the question was, find the solubility at 25 and 45 degrees centigrade. Then solubility at 45 degrees centigrade, I come. This is my 45. Then I draw a straight line from 45 and meet the graph. And when it meets the graph, I go to the solubility in that very line. And that is my solubility. Now to count, remember for me, I had determined each small square to be 0.5, but it will depend on your scale that you have used. I've said, if from here, if this is 30 and for you have 40, and there are 10 small squares, it means 2 centimeters for you represent 10 units. So 10 small squares are having 10 units. So to get what each small square represents, you'll get 10 and you divide by 10 and you get 1. But for me, I used 5. This is 30, this is 35. And there are 10 small squares within, meaning I will get 5, which is from here up to here, and divide by 10, and each small square is 0.5. So if this is 30, 30.5, 31, 31.5, 32, 32.5, 33, 33.5. That will be my solubility at 45 degrees centigrade. The next question. Use your graph. We have answered this to determine the mass of crystals deposited when a solution of P is cooled from 50 degrees centigrade to 25 degrees centigrade. I was very clear last time. I told you to get the mass of salt that are deposited. You get the solubility at higher temperature and you subtract the solubility at lower temperature. The thing is here. I don't know if you even copied the notes. You people, you may not be copying notes. And you know, you need to revise these things. Otherwise, there is no reason why you are studying. If you are not copying notes and revising, then you better pull out. You are wasting your time. So, you get solubility at higher temperature. And in this case, my solubility was 180 at 90. And the solubility at 30 was 25. So I'll get solubility at higher temperature, which is 180, and I subtract 25. We corrected this, that it was supposed to be 25, and I get my answer as 155. So in this case, if you are using your graph, you'll go to the graph, you get solubility at 50, you also get solubility at 25, then you subtract the two. So from my graph, solubility at 50, if I come with that line, I meet my graph at this point and I go to the solubility side. This is, this is 35.5, 36, 36.5, 37, 37.5, 38. So my solubility at 50 degrees centigrade is 38. Solubility at 50 is 38 grams per 100 grams of water. So the solution was cooled from 50 degrees centigrade to 25 degrees centigrade. So I come to my graph again, majestically. I look for solubility at 25. This is 25 degrees centigrade. I come until I meet the graph, and the answer is 20, 20.5, 21, 21.5. So solubility at 25 degrees centigrade is here, 21.5. And you should not contradict yourself. Get the answers from graph. If you write 23 and me, I go to your graph, I find 21, that is a sign of cheating. Do you know what we do to people who cheat exams? We show you the gate. So use your graph. If the question says use your graph, indeed, you must use your graph. So I think this is okay to you now. So mass of crystals deposited when a solution is cooled from 50 to 25 degrees centigrade, we agreed you just subtract So it will be 38, which is for 50. We subtract 21.5, which is for 25. And my answer ended up being 16.5. It is the same question that I asked you in the assignment. I want you to use your graph and hand in. Eh? Now, here we had another question. Calculate the mass of P that would dissolve 45 grams of water at 25 degrees centigrade. What you do, you just go to your graph and you get solubility at 25 degrees centigrade. And remember, solubility at 25 degrees centigrade, from definition, solubility is the mass of a solute that saturates 100 grams of solvent. So when you get the answer, it means 100 grams of water will dissolve the answer that you are going to get from the graph. So from the graph, we had already done that. Solubility at 25 degrees centigrade is 21.5 grams from the graph solubility. And from definition, if solubility is 21.5 grams, remember definition of solubility, it is the mass of solute that saturates 100 grams of solvent. So if the mass of solute in 100 grams of solvent is 21, then that means I will say 100 grams of water, which is the solvent, dissolve 21.5 grams. Then 1 gram I divide by 100 by 100. Then the question is, would dissolve that the mass of P that would dissolve 45 grams of water in 45 grams of water. Therefore, 45 grams of water is 21.5 divided by 100, then times 45. From 1 here, we multiply by 45 both sides, even here, 45 both sides. That was what I taught last time, and I have repeated it. I once again ask, can I have questions? Can I have questions? Because after this, if you still don't hand in your work, we are not going to be friends. Can I have questions from you? What haven't you understood, Steve? Yes, Shadrach. Shadrach, unmute and ask your question.
Teacher,
Yes.
I didn't understand how to get the solubility between 25 and 45.
Between 25 and 45. That's not solubility. The question is the mass, okay, of the solubility of P at 25. So when the question says determine the solubility of P at 25, if you are looking for solubility, remember your graph is for solubility against temperature. So you look for the solubility that tallies with that temperature. The solubility that is in line with that temperature. So at 25 degrees centigrade, I go to the graph and I look for 25 degrees centigrade, which is here. It is here. So from 25 degrees centigrade, I move up until I meet the graph and I read the answer from here. I read the solubility from here. So the answer I get from here is the solubility. It is the one that tallies with 25 degrees centigrade. Then for 45 degrees centigrade, you do the same in that line until you reach the curve, then you read the solubility across. That is it. Then when they tell you that the solution is cooled from 50 to 25, you get the solubility at 50 degrees centigrade, and you subtract the solubility at 25 degrees centigrade. I think I've answered your question.
Yes.
Shadrach?
Teacher, I was asking about the line. How comes it's like near 15 instead of being at 20? Like when you are joining the graph. I don't understand how.
My line, which one is at 15? This one?
We just leave the line or we just attach it to
Oh,
the
this
vertical.
one, eh? You want to know whether you should stop at this point or continue it? Eh?
Yes.
Yes, because I was joining using a free hand. When I reached here, I continued, but you can stop here. Maybe if the question asks for the solubility at 0 degrees centigrade, then the answer will be this one. You get that? So I'm putting that option for if the question asks for the solubility at 0 degrees centigrade. In this case, you would draw your line from 0 until it meets the curve, and the point will be this one. So this is the solubility at 0 degrees centigrade. That's a good question. But you can stop here, it is okay. But if the question asks for solubility at 0 degrees centigrade, then continue your curve in that very line until it meets the y-axis, and this will be the solubility at 0 degrees centigrade. I think you are sorted also.
Yes, teacher.
Are you sorted?
Yes, teacher.
Any other question? I hear some people murmuring in the background. Chantal, do you have a question? Chantal, I hope you have no question. Okay, now that was the work for last week. Please go plot the graph for the assignment I gave you and hand in the correct work. Now, I want to take you to something else, and we are now going to look at preparation of solids. I'm going to give you just an introduction because we have already used a lot of time, but I must give you an introduction also. These are my notes. What I'm going to do, I'm going to send you these notes such that you want page 101. Yes, salts. This is what we have been looking at. So let me give you an introduction about preparation of salts. Yes, here we are. Preparation of salts from metals and dilute acids. Preparation of salts, the method of salt preparation, it depends on whether the salt is soluble in water or not. And you see, when I started teaching you about salts, I gave you the solubility rules. So for you to choose a method which can be used to prepare a particular salt, you must know whether that salt is soluble in water or not. If you don't know that, you are going to fail that question. So, soluble salts that dissolve in water, they are prepared by crystallization and neutralization. You know, from senior one, we looked at a method of fractional crystallization, whereby we said it is used to separate components of a mixture which have different solubilities. So salts which are soluble in water, they are prepared by crystallization and neutralization. Neutralization is a reaction that involves an acid and a base. Yeah? The opposite of an acid is a base, and the acids react with bases. Yeah? So crystallization is the preparation of, so we can use crystallization for soluble salts and neutralization for soluble salts. And we are saying insoluble salts are prepared by precipitation or double decomposition. So here you need to know that some salts are soluble and some salts are insoluble. Soluble salts are prepared by crystallization and insoluble salts are prepared by precipitation. Other salts are prepared by direct synthesis. We shall look at that one also. Preparation of soluble salts. Soluble salts are prepared using dilute acid, acids and metals, or metal oxides, or metal hydroxides, or metal carbonates. What you need to know for today is that we prepare salts depending on whether they are soluble or insoluble in water. Common question. Insoluble salts are prepared by precipitation, and another name for precipitation is double decomposition. Another name for precipitation is double decomposition. And you see how we have even made this bold, very important. General methods, general procedure, how we usually do that. You place some acid in a beaker, the acid should be dilute, then warm the acid and add the metal or metal oxide or metal hydroxide or metal carbonate. Now, I want to give you an example. If you want to prepare a salt of copper 2 nitrate, that means you must use a metal of copper. You must use an oxide of copper, or like copper 2 oxide or copper 2 hydroxide. Then the dilute acid, it should be nitric acid. Such you use any acid that contains a nitrate because you are preparing copper 2 what? Nitrate. If you are preparing lead 2 nitrate, then you should use an oxide of lead, and the acid should be nitric acid. That's what we mean. Then we are saying add metal or metal oxide or metal hydroxide or metal carbonate bit by bit or little by little until in excess, to ensure that the acid is completely used up. Filter the excess metal or metal hydroxide or oxide and collect the filtrate. You know, to filter, you are using a filter paper and a filter funnel. So what dissolves goes through the filter paper, and what does not dissolve remains trapped in the filter paper. So this is the general method. Now, saturate the filtrate by evaporating and allow the solution to cool. Saturate the filtrate by evaporating and allow the solution to cool. So, saturate, I told you, a saturated solution is a solution that cannot dissolve any more solid. So, to saturate the filtrate, we are saying you heat that saturated solution to drive off the water. To drive off the water, and you remain with a solution that does not contain the water. Then when you cool that solution after heating, it starts to form crystals. Now the crystals that are formed, you filter the crystals and wash them with distilled water. This water should be distilled here. This should be distilled water here. Should be distilled water. Then dry the crystals in an oven by placing them between filter papers. We are not going to say under the sun, because what if it is raining? What you do? So you dry the crystals by placing them between filter papers. Place, I mean PRESS. Okunyiga. You place the crystals between two filter papers. Now, we have given an example here. Let's say you want to prepare zinc sulfate from a metal. So what do you do? If you are preparing zinc sulfate, the acid you use is dilute sulfuric acid, because you want a sulfate. You should use an acid that contains a sulfate. Put dilute sulfuric acid in a beaker and heat gently until it is hot. Then when the acid is warm, you add zinc powder, because you want zinc sulfate. Don't add lead now when you want zinc sulfate. That is very wrong. How can you add? You want zinc sulfate, then you are adding lead? No, that is very wrong. Okay? So add zinc powder to the hot acid bit by bit while stirring. I told you what stirring means, until zinc powder is in excess. Zinc powder being in excess, we mean you add zinc until the reaction cannot continue, until the reaction stops. And how will you know that the reaction has stopped? It stops producing hydrogen gas until bubbles cannot form anymore. Then filter off the excess zinc using a filter paper to obtain zinc sulfate solution as the filtrate. Then saturate the filtrate by evaporating off the water. To saturate means to make it concentrated by evaporating. Then allow it to cool and form crystals of the salt. Filter the crystals and wash them with distilled water. I told you the water must be distilled. Then dry, because this normal water sometimes contains impurities. Dry the crystals by pressing them between filter papers. Then you write the equation, and by doing that, you have prepared zinc sulfate solution. This is how we prepare zinc sulfate solution. We usually give this question 6 marks. And you know what it means by 6 marks in chemistry with our halves. So take note of that. So time is up for us. Maybe my assignment to you is you prepare for me zinc 2 chloride. Zinc 2 chloride, now it means you use hydrochloric acid